All right, so 5-2 talks about perpendicular and angle bisectors. So we talked about perpendicular bisectors to the isosceles triangle before, where the perpendicular bisector of the base also bisects the angle of the vertex. And so that kind of does a double duty. So in an isosceles triangle of the vertex angle, the perpendicular bisector also bisects the angle. So it's both. It does a lot of stuff. Not necessarily true in all triangles, but look at the question here. What's that notation saying? Yeah. Well, since we had a ray, right? So ray BD is the blank. You're either putting bisector or bisects of the picture there. So ray BD, is it the bisector or is it the bisects? That's the top one. It's the bisector. Of course, we can't assume that based upon the picture. Why? Yeah, there's no arc marks here. For us to be able to assume that, there'd have to be a little arc mark here, right? Well, we only have two choices here, so that's the reason why we can make that assumption. In your hat, the hoodie needs to be off. What's this notation saying here? There's nothing in front or up top. What is that notation? The distance from B to D. It's a distance. So it's saying the distance from B to D, bisector angle ABC or bisects? Well, that's weird. It must be missing notation. Because the distance doesn't bisect something, does it? So we're definitely missing notation. So please add up here a ray. So ray BD bisects the angle. So then write true or false down here on your own. So what do you think about number 3? Two perpendicular segments intersect to form 4 right angles. So here would be one segment, here would be another segment. If they intersect, if they're perpendicular to each other, you would have one right angle there. Is it true that all 4 angles are right? Yes, so that is true. To determine if this is true or false, you can draw more than one line perpendicular to a given line. So here's your given line. Through a point not on the line. So just choose a point anywhere not on the line. So that you can draw more than one line perpendicular to this line from that point. Is that true or false? So here's one. We're doing a line. Yeah. So here's one. There's one. Where's the second one? Or the third one? Or the fourth one? If I go anywhere else here, is it going to be perpendicular to that line? It will be? That's perpendicular? No. How else would it be perpendicular? So some of you are saying yes, there's more than one line. That's not a line I can think of. Well, going this way, but it has to be one line perpendicular to the given line. So yes, you could draw a line that would be perpendicular to this line, but it's not perpendicular to that line, it's parallel. Does that make sense? So this one's false. You can only draw one line perpendicular to another line from a point, not on that. Now if I had several points on that line, then yes, I can do an infinite number, but it's from that one point to that one line. And the reason for that is this right here, from here to here, that's considered the distance from the point to the line. So for all of us to agree on the distance from this point to this line, there has to be only one distance, one way to find that measurement. And so that's the definition of the distance from a point to a line, is the perpendicular segment that joins that point to that line. And so there is only one. So then your vocabulary today is equidistance. What does equa mean? Equal. The same. Distant? Distance. So it means same distance. So we're going to use that a lot today. Equidistance means you're an equal distance from a single point or an object. So as you look at the two diagrams below, you can be equidistant from any point on this number line. So if I looked at 0 right here, wouldn't B and C be equal distance from 0? They're both how many units away? 1. Would A and D be equal distance? They're both how many units away? 3. 3 units away from 0. What about equal distance from point C? So now I'm looking at point C. What points are equal distance from point C? So B and D, and how many units are they away? 2 points. 2 units. Then you can look at the coordinate grid instead, and you can say, okay, look at point Q. Which points are equal distance from Q, and how do you know? What points are equal distance from Q, and how do you know? P and R are equal distance. How do I know that this distance and this distance are equal? Do a what? Okay, so if I went from Q to P, I would go down 2 and to the left 2. And didn't we use this like several weeks ago to find a missing point? And what this does is I've got one leg of this triangle and this leg of this triangle. So that's a 2 by 2 distance. If I go a 2 by 2 distance on the other side, don't I end up with having those two sides equal? And aren't these two sides equal? Right? In these little right triangles. So aren't these two triangles here equal by SAS because that's a right angle? So aren't the corresponding parts congruent? So we can get a roundabout way of doing that as well. So what points are equal? What point are all points Q, R, S, and P equal to? Equal distance to? The origin. So all 4 of the points are equal distance from that origin. All 2 units away, and that's your north, south, east, west. All right, so flip it. Brings us to a theorem. So here's what the theorem says. If a point is on the perpendicular bisector of a segment, so your point has to be somewhere, if you look at this picture, this is the perpendicular bisector of this segment. It's showing that it's a perpendicular bisector because this line is perpendicular to that line with that notation. And that this line here has been bisected because those pieces are equal. It's been bisected at the point M. And so it says if I choose any point along this perpendicular bisector, that perpendicular bisector is the knife, it's the cutter. Then it is, that point, is equidistant from the endpoints of the segment. So these are the endpoints of the segment. You have to have endpoints that are equal distance from that midpoint there. And all it says is I can choose any point here. Well, they've chosen point P. So they chose point P, and then over here they drew the distance from A to P and the distance from P to B. What this theorem is saying is that those distances are equal. You no longer have to say that those angles are equal and therefore the sides opposite them are equal. It creates this isosceles triangle. But we could have a formal proof behind this, and the formal proof behind this will prove that the triangles are congruent by SAS, and therefore corresponding parts of congruent triangles are congruent. So think about it this way. Don't these two triangles share this side? So wouldn't you agree that this side here is equal to both triangles? We've already shown that this segment has been bisected, so those two sides are equal. And we've shown that this is perpendicular, so there's a right angle. Aren't all right angles congruent? So aren't these triangles congruent by SAS? Therefore, all the corresponding parts are congruent. And it wouldn't matter where I put this. So consider me moving P anywhere along here. I could move P all the way up to, let's extend this. Oh, that's a green. So I'm going to extend this line P all the way up here. And I'm going to put Q up here. If I drew the distance from Q to A and the distance from Q to B, the distance from Q to A and the distance from Q to B are also equal. Well, I'm running out of tick marks. I have to have 4 tick marks. But these are equal as well for the same reason. Again, QM, they share. This distance from A to M and M to B are equal, and then we still have the right angle. So by SAS, QA and QB are corresponding parts on those triangles. They're congruent. It doesn't matter where I put the point on this perpendicular bisector, these distances are always going to be equal. So the minute you can state that this is a perpendicular bisector, you can immediately state these hypotenuses, still don't like that word, are equal based upon this theorem. Then this is the converse of that theorem. And it just says, okay, if I find that a point is equal distance from the endpoints of the segment, then I can conclude that that point is on a perpendicular bisector. So the piece that's missing here is perpendicular bisector. So I use shorthand notation. And so if you look at the picture here, this point P is the same distance to R as P is to T. So therefore P must be on some imaginary perpendicular bisector. So if I were to draw the distance from P to this line and make it perpendicular, then I can also conclude, then let's call this point here Q. I can conclude that RQ and QT are also equal. So let's explore how this works in some problems. Any questions about that before we explore how it works? Okay. So instead of filling in the little table that we have here, let's just look at the picture. We are going to find, and again, notice they're not asking us to find n. They're asking us to find the length of line segment QR, and that would be this length there. What do I need to find the length of QR? What do I need? If I knew what, how could I find the length of QR? N. So I've got to solve for n. So looking at the picture, please note that we have these pieces are equal, so that implies that S is a midpoint. And I have a right angle there, so that implies that SQ is what? It's a perpendicular bisector of line PR. So, since I've concluded this, or since I've made that observation, I can then conclude, so therefore, therefore PQ is congruent to QR. The distance from P to Q is exactly equal to the distance from Q to R. So I'm going to put in double tick marks here. They're not going to tell you this. You know it because you have a perpendicular bisector. So Q is equal distance from those planes. So then step 3, I can set those equal to each other. 3n minus 1 is equal to 5n minus 7. So please finish the problem. Find the value of n, and then answer the question. So you finish it up now. Everybody put it. Ian. And Gigi. If you want to observe, just go to online. When you get an answer, share it with those around you. No. For your note purposes, we wrote that down. You don't have to execute it. Say that again.
You could also just say like SQ is extended bisector, therefore creating two segments.
No, because we want it to be a perpendicular bisector because by definition of the theorem, if it's a perpendicular bisector, not just a bisector, it creates that right angle. And because of the right angle and the fact that it bisected that segment, then those sides are equal. If that's just a bisector, remember that can be tilted any way. And the minute I tilt it this way, those sides are no longer equal distance. So both things have to go into place. Nope. So I'll show you that here in just a minute. All right, so stop. Olivia's brought up a question, so let me answer this question first, and then we'll talk about what her question is. So here's the answer. The value of n is 3, but that's not the answer. You then have to plug that into what QR is, and QR is 5n minus 7, so 15 minus 7 is 8. So if that has a distance of 8, then this has a distance of 8, and you can easily check. If I put 3 in for n here, does that also have a distance of 8? Yes, so that's a good way to check your answer, especially on a test. Now, Olivia, ask your question again.
Can you consider SQ also a segment bisector? You would have to be like specific to.
If I only consider this a segment bisector and not perpendicular, then that segment bisector could be off a smidge here. And now PQ, because Q would be on my yellow line here, PQ and QR would no longer be equal distance. So if it's just any segment bisector, if it's just bisecting this segment over here, one over here, and it's not perpendicular to it, I can't conclude that these sides there are equal. The only way I can conclude that these sides are equal is if this is both perpendicular and bisects that segment it's cutting. It has to be both. If it's just a segment that's been bisected, then all I can conclude is that those two are equal. I can't make the additional conclusion that those are equal. Does that make sense? Is that answering your question? Okay. All right, so we're good with that. All right, so then look at problem 2. A word problem, our favorite. Let me ooch this up a little bit. All right, so the director of the park at the right wants a t-shirt stand built at a point equidistant, there's our little word for the day, from the spaceship chute and the roller coaster. So on our picture, here's the spaceship chute, say that 10 times fast, and here's the roller coaster. So we want it equidistant. So it could either be here, right? That point right there on the line that's directly between those two. Or it could be anywhere along the perpendicular bisector of the segment that connects the roller coaster and the spaceship chute. So I could do it anywhere along this line here, extended into infinity, or however long that park is. So it says, by the perpendicular bisector theorem, he can place the stand anywhere along line L. So we can place that stand anywhere along here. Because anywhere along here is also going to be equidistant to those two points. Suppose the park director wants the t-shirt stand to be equidistant from the paddle boats. Well, here's the paddle boats. And the spaceship chute. So so here. So wouldn't that create a new segment from here to here? Oops. Picking out a document. Say whoops a lot. So if we wanted to So we drew on the diagram the distance from P to S. And what's not clear in the question is, does he want an equal distance from the paddle boats and the spaceship chute and the rolling roller coaster? In other words, he wants something that's equal distance to all of these. Would this line right here be equal distance for those 2 points? Would this line here create equal distances between those 2 points? In other words, is this line perpendicular to this line? Yes or no? Is this right angles right there? No. So if I place the t-shirt stand anywhere along this line, it will only be equal distance to the roller coaster and the spaceship chute. If I place it anywhere along this line, it will not be equal distance to these, so we have to create another perpendicular bisector. And so the question says, suppose the park director wants the t-shirt stand to be equal distant from the paddle boats and the spaceship. We could use that pink line. We'd have to find this distance. Use a ruler that can actually be on top. So this is about, give or take, 5 centimeters long. What's half of 5 centimeters? 2.5, so here's right about there. There's my midpoint, so we cut that in half. And then, of course, we have to create a perpendicular bisector, a perpendicular line. But we're going to eyeball it. So wouldn't that be the line right there, give or take? That would be both perpendicular and would bisect that distance. Do you see how the 2 lines are not the same? So he has to make a choice. Either you're going to be equal distance to the paddle boats and the spaceship, or the roller coaster and the spaceship. One of the 2. But he can't have both, can he? Can he have both? Where do the lines intersect? Right? So where the lines intersect would be X marks the spot right here. So he actually could have the best of both worlds, couldn't he? If he chose to put that t-shirt stand right here at the purple, then it would be equal distance between all 3 points, because that is the one point that is on both perpendicular bisectors. So it can be done. All right. I think we've answered all those questions in here too. So let's scroll down all the way down to here. So that brings us to another theorem. What if we have an angle bisector instead of a segment bisector that's also perpendicular? If a point is on the bisector of an angle, then the point is equal distance from the sides of the angle. So here's the bisector of the big angle PQR. So same thing as a perpendicular bisector. If this is bisecting an angle from here to here, then anywhere along this, and they just chose point S at random, this point along this angle bisector is equal distance to the endpoints that they determine on the angle. Now, you and I both know that there are numerous places I could put an endpoint because these are rays. So they chose this endpoint and this endpoint. Notice that these distances from a point to a line are what kind of distances? What kind of distance is this and this? They're perpendicular, aren't they? The only way that you can show the distance from a point to a line is if it's perpendicular to that line. So I couldn't choose from here to here and say, oh, that's not equal distance to this one. Well, this one's not perpendicular, that one is. So when you're determining the distance 1 and distance 2, those distances must be perpendicular to the line. So you you have to draw it that way. So that's going to be difficult for some of you to draw those distances perpendicular because it's a spatial thing. So the question says, if point S is on the angle bisector of, what angle is it bisecting? This is on the angle bisector of, what's it bisecting? What is it? PQR. Then the distance from S to P is equal to what? The distance from S to R. Then look at the converse. And these all go on flashcards. Both the regular theorem and its converse, because you've got to be able to read them forwards and backwards. If a point on the interior of an angle, so if I had any point that was in the interior of the angle that hadn't drawn in that angle bisector, is equal distant from the sides of the angle, then the point is on the angle bisector. So for instance, it might look like this. So draw an angle, any angle. Let's draw an acute angle. And let's say that I drew a point here, and I had the following points. So I have A, B, C, and this is point D. So point D is on the interior. If I could prove that this distance from A to D, and mind you, that distance would have to be perpendicular, and this distance from B to C, and that distance would have to be perpendicular. If I can prove that these distances are equal, then my conclusion is that D to B is an angle bisector. And as an angle bisector, these angles, those angles there are perpendicular. But I'd have to be able to prove this part first. Then I can conclude that that's an angle bisector, and then I can say that those angles. All right, so last page. The question is, what is the length of line segment FB? So here's FB from here to here. What do I need to find the length from F to B? X. So looking at the picture, what do we know? F, BF, and FD are what? They're perpendicular to CD and CD respectively, right? So I know that those are distances because these are perpendicular segments. So these are distances. I don't know yet that they're equal. But look here. What's happening with CF? What do these tell me? So isn't that telling you that CF is an angle bisector? So first conclusion I can make is that segment CF, or ray CF, is an angle bisector just based upon the picture. So the minute that I realize that CF is an angle bisector, then any point on that bisector is equal distance to the sides of that angle. And so since these are distant markers, these are perpendicular, and they're coming from the same point, I can conclude that those BF and FD are congruent. So I can conclude that the distance from B to F is congruent to the distance from F to D. So then that means I can set them equal to each other. So 4x plus 9 is exactly equal to 6x plus 3. So now solve that. And answer the question. Share your answer goes around here. Share, share, share. What did we get? What did you get for the value for x? 3, and what did you get for the value of f(b)? 21 is correct. So those are just easier examples of what you're going to get in your homework. The last thing I want you to do is do your lesson check. So look at the lesson check number 21. I want you to answer the following questions. See if you get it. Look at the picture to the right. Come on, Brody, let's go. So here are your answers. Most of those questions are easy. The harder parts of the question would be the last two. BD, segment BD divides segment AC into two non-congruent segments. Those are visually easy to understand. The last part is you need to understand what's the knife and what's being cut. Because BE and ED are equal segments, that leaves AC as the perpendicular bisector of the part that's been cut, which is BD. So long as you realize that, life will go a whole lot easier today. So make sure you complete tonight's assignment. Complete it tonight.